All right, section 3.1, the complex numbers. All right, so when we say complex numbers, this is the, I guess, alternative to the real numbers, okay? A lot of the times we'll say that there are no real solutions, right? Or real numbers. Okay, this is the complex numbers. This is actually expanding what we know about numbers. And it starts off by the claim that we have been lying to you all along about the square root of negative numbers, okay? We always say that you cannot have a square root of a negative. Well, it turns out you actually can have the square root of a negative. And in this case, we're going to call the square root of negative 1 I. Okay, so I is just a shorthand for the square root of negative 1. I for imaginary. These are imaginary numbers. I'm not making that up. It's just a weird term that we use. They're not actually, quote, imaginary. It's just that they're not real numbers. Anyway, so I'll let you kind of chew on that for a little while. The important thing about this, though, is that if you think about it, right, if I is the square root of negative 1, well, then if you square the square root of negative 1, you should get negative 1, right? That should equal negative 1. So in other words, I squared is negative 1. Okay, and this allows us to do math, algebra, or anything really, any kind of math, with the square root of negative numbers, right? Where you have a solution that is imaginary. Well, you can still use that information. All right, so anyway, let's kind of just talk about the background. So this is the basis for everything we're about to talk about. Let's go to our first example. Example number 1, the square root of negative 21. I want to find the square root of negative 21. All right, so I'm going to go ahead right away and split this up into the square root of 21 times the square root of negative 1. Okay, that's allowed. That's technically the same thing. And we just said that the square root of negative 1 is I. And so this thing here is the square root of 21i. You want to be careful to not put this I under the square root, right? That's not the same thing at all. That would be the answer. Another way you may see this written as I, the square root of 21. Okay, so these two are equivalent. Those are the acceptable answers, right? Do not put square root of 21i with that all under the radical. All right, anyway, that was a little bit of a monologue. Example 2. We have the square root of negative 100. Okay, well, let's split this up again. Square root of 100 times the square root of negative 1. I happen to know the square root of 100 is 10, and the square root of negative 1 is I, so this is actually 10i. What about negative the square root of negative 59? I'm putting those two negatives back to back intentionally. I'm trying to confuse you a little bit because you tend to see two negatives and want to change it into a positive, but that's not what's going on here. A negative inside the radical, a negative outside the radical, they are not touching, right? They don't count. You can't just change that. So I'm going to do that like before. Negative square root of 59 times the square root of negative 1. And square root of negative 1 is I. So negative square root of 59 I, or you could say negative I, the square root of 59. Can't draw a rectangle today. Okay, let's do some more of these. Example 4, negative square root of negative 9. Okay, again, the two negatives cannot interact, so I will just keep them separate for now. Negative square root of 9 times the square root of negative 1. Negative, okay, square root of 9 is 3. Square root of negative 1 is I. So negative 3i. And then let's do one more. The square root of negative 28. All right, so this one's a little trickier. Okay, so I'm going to start off the same way. Square root of 28 times square root of negative 1. So that's going to take care of that I thing, right? But 28 can actually be simplified, okay? We can simplify that. Remember what 28 is. It's 4 times 7, right? 4 times 7. So I can actually break this up as the square root of 4 times the square root of 7 times the square root of negative 1. Why would I do that? Well, the square root of 4 I can write as 2. Square root of negative 1 is I, so this is really 2 the square root of 7i, or I think you'll more likely see this, 2i the square root of 7. Same thing, but yeah, usually the one on the right I think is what you see more often. Okay, so that's simplifying I using the square root of negative 1 being equal to I to simplify these radical expressions. Okay, these square roots specifically. So let's now go on to what a complex number is. So all of these are just kind of sort of imaginary numbers. Okay, they deal with I. Let's talk about complex numbers. So a complex number is a number that has the form a plus b I, where a is a real number and b is a real number. A and b are real numbers. Okay, and then b has an imaginary part. So there's a real part. A is called the real part of the complex number, and b is the imaginary part. Use a capital R, so I'm going to use a capital I. Imaginary part. And I just said part and wrote the word number, but I meant part. So real part and imaginary part. All right, so for example, you might see something like negative 6 minus 5i, right? Negative 6 here, that's my real part, and then the negative 5i, or just the negative 5, would be the imaginary one. Okay, so let's actually do something with this. This is actually part of a bigger example, so let me actually write it out. I'm actually adding together two complex numbers. Negative 6 minus 5i, that's my first one, plus 9 plus 2i, that's my second one. This looks a whole lot like adding polynomials, okay? The rules are actually the same. Okay, so how would I add polynomials? Well, I'd first drop the parentheses because they're kind of unnecessary, right? It's just understood one's multiplied on the outside, so I can leave them off. And then I go and I combine my like terms, right? Negative 6 plus 9 is a positive 3. Negative 5i plus 2i is a negative 3i. So you can add complex numbers together, just like you can add real numbers together. Okay, same thing. You can add them, you can subtract them, multiply and divide. We'll do all that as we go. Okay, let's do another example. Example 7. We have 7 minus 2i plus 4 minus 5i. Then we drop the parentheses again. They are pointless here. Okay, 7 plus 4 is 11. Negative 2i plus negative, well, minus 5i is negative 7i. So we have 11 minus 7i. I like example 8. Example 8 says 7 minus the square root of negative 36 plus 2 plus the square root of negative 9. I like this problem because I have to take care of those radicals first. Now I'm not going to actually do the extra work of splitting up the square root of negative 36 into square root of 36 times square root of negative 1. I just know that the square root of 36 is 6, and I know that if it's negative, it's going to have an I. Same thing here. Square root of negative 9 is a positive 3i. All right, be careful with the signs, right? Again, avoid the temptation to write that as a plus because you see those two, right? Don't do it. That minus sign stays there. This minus or negative turns into an I. Okay, they go two different places. All right, same thing's true here. This turned into the I, that stayed a plus. All right, like terms, 7 plus 2 is 9. Negative 6i plus 3i is negative 3i. So 9 minus 3i. Let's do example 9. Oops. I'm going too far down. Example 9. Negative 7 plus 12i minus, be careful there, minus 3 minus 6i. Okay, that minus sign is outside of these parentheses here, so I think about that as a negative 1 that gets distributed. Okay, so what does that end up looking like? Minus 3 plus 6i. Minus 3 plus 6i. Okay, so negative 7 minus 3 is a negative 10. Positive 12i plus 6i is going to be a positive 18i. So negative 10 plus 18i. And let's do one more of these. Example 10. 10 minus 4i minus 8 plus 2i. 10 minus 4i. Okay, distribute the negative again, right? So minus 8 minus 2i. 10 minus 8 is 2. Negative 4 minus 2i is negative 6i. So 2 minus 6i. All right. So we've added and subtracted complex numbers. Let's go on to multiplication. We do need to be careful. The rules here get a little tricky, okay? Not a whole lot, but just a little tricky, okay? You know that, well, let's just work out an example, and then maybe we can see what we're talking about. The square root of negative 49 times the square root of negative 9, okay? And something I want to avoid. I know that if I multiply these two together, okay, let's say I multiplied them together, and I ended up with something like this, negative 49 times negative 9. You can't actually do that, right? It doesn't work when you're dealing with imaginary numbers. Now, you can split it up into like a positive and a negative for each of them, okay? But what you can't do is go in reverse, okay? You can't take these two that have a negative inside, put them together, and then say the negatives cancel. Okay, it just doesn't work. So let's take care of these one at a time. 49, square root of 49 is 7. And since it's negative, it's 7i. Okay, times negative 9, right? Square root of negative 9 is going to be 3i. 7i times 3i is 21i squared. All right, let's go back to the beginning. What did we say about I squared? I squared equaled negative 1. So this is really 21 times negative 1. So my answer is a negative 21. Negative 21. All right, let's do another one. Just like that one. Square root of negative 16 times the square root of negative 100. For I times 10i is 40i squared. But wait, what is I squared? Negative 1. So that's really 40 times negative 1. That's negative 40. Right? If you were to multiply these two together, right? Let's say you did it that way, the wrong way. Let's say you did it the wrong way, and you ended up with the square root of positive 1600. And the square root of 1600 is a positive 40. You see, you kind of get the wrong answer. You get the wrong sign. Okay, so just be careful with that. All right, let's move on. Negative 6i times negative 5 plus I. Okay, so this is another, this is two complex numbers multiplied together. So I'm going to distribute the negative 6i. Negative 6i times negative 5 is a positive 30i. Think about that as like 6x, right? Negative 6x times 5, negative 5. right? You would just multiply it and get 30x. So the rule is exactly the same. Okay, so don't let that confuse you. It's nothing new. Negative 6i times I is negative 6i squared. But wait, anytime you see an I squared, that's really a negative 1. So this is really negative 6 times negative 1, which would be positive 6. So 30i plus 6. Right? Okay, so now this is technically not written in the right form. Okay, so let's put it in complex number form, where you put the real number first, which is 6, and the imaginary part second, 30i. All right. 14. 3 minus 5i times 8 minus 2i. This looks a lot like distributing, right? Looks a lot like that binomial times binomial. So I need to do the distributive property. 3 times 8 is 24. 3 times negative 2i is negative 6i. Negative 5i times 8 is negative 40i. Negative 5i times negative 2i is a positive 10i squared. All right, so I see this I squared. I immediately know that's going to turn it to a negative 1. So this is going to change into a minus 10, right? That's kind of how you want to think about this. Whenever you see that I squared, just change the sign without actually going through the whole process of working it all out. Save yourself some space. So 24, negative 6i minus 40i is negative 46i. And this plus 10i squared, well, that turned into a negative 1, so that makes this a minus 10. Oh, more like terms. 24 minus 10 is 14. So if I multiply these two complex numbers, I get a new complex number. All right, let's do one more of those. 15. 7 minus the square root of negative 16 times 2 plus the square root of negative 9. Okay, if you haven't by now figured out that these can be quickly turned into imaginary numbers, and then from there you can work out, just like you normally would if it was a binomial and a binomial. Well, if you haven't figured that out yet, now's a good time, right? Distribute. Well, no, don't distribute yet. I got excited. Square root of negative 16 is 4i. And square root of negative 9 is 3i. Let's do the whole distributive property thing. 7 times 2 is 14. 7 times 3i is 21i. Negative 4i times 2 is negative 8i. Negative 4i times 3i is negative 12i squared. Okay, so 14. 21i minus 8i is going to be 13i. Positive 13i. Minus 12i squared. Oh, there's that I squared again. So this negative 12 is going to turn into a plus 12. 12 plus the 14 is 26 plus 13i. All right. So hopefully we can handle that. Not too bad. All right, so another type of question. Sometimes we want to simplify an imaginary number. And by that I mean simplify something like I to the 7th power. Okay, and you really need to think about the exponents here. Like, you really got to think about the exponents. Okay, because what ends up happening, let's kind of think this through for a second. I'll do this off to the side. I is equal to the square root of negative 1, or just I. I squared equals negative 1. We know that. What does I cubed equal? Well, that's I squared times I, right? I to the 1st power. You add those exponents together, you get I to the 3rd. So that's negative 1 times I, which is just negative I. See how it's simplified, right? It's just a negative version of the original. What about I to the fourth power? Well, that's I squared times I squared, which is -1 times -1. It's +1. What about I to the fifth power? Well, that's I to the fourth times I. And I to the fourth, we just figured out, was 1. So that's 1 times I. So I to the fifth is actually the same as I. It's a vicious cycle. It just goes on forever. It alternates between, or cycles through I, -1, -I, +1. I, -1, -I, +1, and so on. Okay, it just goes down the line. So I kind of just answered this question already, but I to the seventh power actually just equals -1. Okay, let's do a more complicated example. I can write it actually right under it. Example 17 says I to the 24th power. All right, so now it's a little tricky, right? But remember what we said. Every time you go through 4, or get x to the 4, not x. Every time you get I to the fourth power, it equals 1. So it basically cancels out. So let's go back to I to the seventh for a second. All right, for I to the seventh, I thought about it as, what's a multiple of 4 that's smaller than 7? Oh, it's just 4. I thought about it as I to the fourth times I to the third. The reason why I did that is because I knew, let me get rid of that, that this would be 1 times I to the third. These two are the same. These are the same. I to the third. Every time you get I to the fourth, you are now back to, or you can eliminate that. All right, so then I'm at I to the third. That's one I have to remember. That's -I. Okay. Oh, look at that. I wrote the wrong answer down. Y'all didn't tell me. Probably kind of hard to do when you're watching a pre-recorded video, but whatever. I'll blame this on you. It's easier that way. Okay, so I, -1, -I, 1. I, -1, -I. There we go. All right, so there's the process. So -I was the answer that I was supposed to write earlier, and y'all will all pretend that that's what I always had. Okay, cool. Let's do the same process here. We have I to the 24th. I want to figure out what is a multiple of 4 that goes into this, okay? So the easiest thing to do is just divide it by 4. If I divided the 7 by 4 earlier, that would have gave me 1, that represents this one, with a remainder of 3, okay, which would give me I to the third. We'll do the same thing here. If I divide 24 by 4, it divides evenly. That tells me that 24 divided by 4 is 6. That tells me there are 6 I to the fourths that I can write. Let's see, 1, 2, 3, 4, 5, 6. Yeah. Okay, and if I added them all up, 4 plus 4 is 8, plus 4 is 12, plus 4 is 16, plus 4 is 20, plus 4 is 24. Right? They are the same thing. So what did I just do? I just told myself to write I to the 24th as 1 times 1 times 1 times 1 times 1 times 1, which is just 1. It's just 1. Kind of weird, right? Sure, let's do another one. What about I to the 42nd power? Oh, that's fancy. Okay, well, let's divide 42 by 4. Okay, the closest I can get is like the 40 and I squared. 40 and I squared, right? Why'd I pick 40? Because 40 is divisible by 4, which means this is going to equal 1, right? If it's divisible by 4, it's going to equal 1. And then I had 2 left over. Okay, I got as close as I could get to 42 without going over, and I have 2 left over. Okay, so then this is 1 times I squared, 1 times -1, right? That's -1. So -1. Okay, to another one. Example 19. Ooh, this is tricky. -I to the 6th power. Okay, so we need to talk about what we know to do with negative values raised to an even power versus an odd power. So let's recap that real quick. Whenever you raise a negative number to an even power, you will always get a positive result. If you raise a negative number to an odd power, you get a negative result. That's for real numbers, okay? So what I want to do is break this up into a real number, and then we'll deal with that I thing later. Okay, so this is -1 to the 6th power times I to the 6th power. Okay, well that -1 is going to become a +1. And I to the 6th power, well, I got to deal with that. Let's deal with it the way we've been doing that earlier. Remember I to the 6th? Yeah, I know I did this problem earlier, but whatever. Let's work it out. I to the 6th is the same thing. Okay, what's a multiple of 4? That's as close to 6 as I can get without going over. That's 4, right? I to the 4th times I squared. Okay, if it's a multiple of 4, then it really equals 1. So it's really 1 times I squared. Of course, I squared equals -1. So 1 times -1 is -1. Voila. Okay, let's go to a new page. Example 20. One more of these, so 2I to the 5th power. All right, and again, I said we should break this up as 2 to the 5th power, I to the 5th power. Now, how can I break this up even further? Well, 2 to the 5th power is easy, right? 2 times 2 times 2 times 2 times 2 is 32. I to the 5th power, okay, I need a multiple of 4. That's as close to 5 as I can get without going over. That's 4. That means I have 1 left over, right, to get 5. I need 1 more to get to 5. Okay, so this equals 1. So that's 32 times 1 times I. 32I. Okay, so there we go. That would be the last of those types of problems. There's one more thing we need to go over in this lesson, and that's called conjugates and division. We actually divide complex numbers using conjugates. Okay, so what is a conjugate? If I have a complex number a plus bi, its conjugate is a minus bi. It's the exact same thing, except you change this middle sign, and only the middle sign. Okay, you change the sign in front of the imaginary part. Okay, that would be the conjugate. So if I had 2, or let's say if I had 2 minus 3i, its conjugate would be 2 plus 3i. These two are conjugates of each other. The fancy thing about conjugates is if you multiply them together, let me multiply these together. If you multiply them together, it eliminates the imaginary part altogether. You're left with a real number. A complex number times its conjugate will give you a real number. All right, let me do this quick. 2 times 2 is 4. 2 times 3i is 6i. Negative 3i times 2 is negative 6i. Negative 3 times positive 3 is negative 9 i's are squared. And of course, I squared is a -1. So that's going to make this turn into a positive 9, right? And so 4 plus 9 is 13. Those two cancel out. Okay, that's the whole benefit of a conjugate. So we can use that to divide and get nice answers. So let's do that. Example 21. A lot of examples in this section. 21. I divided by 2 plus I. Okay, so the way you carry that out is you have to get rid of that I in the denominator. It's considered improper. So how do I do that? I multiply the top and the bottom by the bottom's conjugate. Right? I want to get rid of this imaginary part in the denominator, so I multiply the entire fraction, right, the division, by the conjugate of the bottom. Now, we already know what's going to happen, right? The imaginary part's going to cancel out. Now, let's actually do it. Let's see, the top, I'm going to distribute the I times 2 is 2i. I times negative I is negative I squared. I'm going to deal with that in a second. On the bottom, if I distribute, 2 times 2 is going to be 4. 2 times negative I is negative 2i. I times 2 is 2i. I times negative I is negative I squared. You may recognize what we just did. These are difference of squares, right? Difference of squares. So you don't have a center term if you think about that from way back in factoring. All right, so anyway, those cancel out. This becomes a negative 1. This becomes a negative 1. Let me not do too much at once. This is 2i minus negative 1 over 4 minus negative 1, right? The I squared is turned into negative 1. Yeah. So this is really a positive 1. So that's 1 plus 2i to put it in the right form, right? You want to have the real part first. So 1 comes first. 1 plus 2i over, this becomes a plus. Oop, can't see the 1 anymore. There we go. 4 plus 1 is 5. Now, this is technically not in the a plus bi form, right? So let's put it in that form. In other words, let's break this up, understanding that this is a fraction and this is a fraction. This is the same thing as 1/5 plus 2/5 I. Okay? Again, all I had to do is understand that this is divided by 5 and this is divided by 5 as well for that to work. All right, one more example. Let's do one more. Last one. 22. Forgot how to count. That's not a good sign. All right, 5 minus I over negative 7 plus 2i. All right, so what am I going to do here? Well, multiply by the conjugate. Negative 7 minus 2i, right? Just changing that middle sign. And it's valid as long as I do it to the top and the bottom, okay? Again, this is just a fancy version of saying this thing times 1, right? That's all it is, because anything over itself equals 1. So I can multiply it times 1, get the same value, although it looks different. I'll put some parentheses. Sometimes it helps people see better what's going on. All right, so 5 times negative 7 is going to be a negative 35. 5 times negative 2i is a negative 10i. Negative I times negative 7 is a positive 7i. Negative I times negative 2i is a positive 2i squared. Over negative 7 times negative 7 is a positive 49. Negative 7 times negative 2i is going to be a positive 14i. 2i times negative 7 is a negative 14i. Haha, those will cancel. And then 2i times negative 2i is a negative 4i squared. All right, too much going on there. Let's kind of just ignore it. All right, so up here we have negative 10i plus 7i. That would be a negative 3i. Okay, this negative 35, well, what happened here? That becomes a negative 1. Let me do this in red. This becomes a negative 1, so that just makes this a minus 2 instead. So negative 35 minus 2 is negative 37. Notice I put the real part first. Okay, down here, these cancel out. Wonderful. All right, 49 minus 4i squared. Wait a second. How about plus 4? How about that? Right, so, because it's a negative, right? Negative 4 times negative 1 is a plus 4. 49 plus 4 is 53. Oh, that's ugly. Let's fix that up. Negative 37 over 53 minus 3 over 53 I I know I said I was going to fix this up, but I meant let's make it more ugly. All right, so that would be complex numbers. So hopefully that wasn't too much. Of course, feel free to watch through all this again and just ignore that little mistake I made. Again, remember, that was all your fault. Remember that? Okay, cool.